Hello and welcome to lesson 4. In this lesson we're going to get things moving. The title screen that you're looking at is created using the commands that you've studied plus a new one that we're going to go over in this lesson. And the point of this lesson is to create titles. Without a good title you can't have a good movie. So first we'd like you to go to google.com and type in great movie title sequences and search and study them. Then the second thing that we'd like you to look at is the history of film, which is very interesting, and we're going to be talking a little bit about the history of film this lesson. And you also need to upload the new Lesson 4 software, which has the new commands and some modifications to some of the old commands that we're going to be using to create the motion in this lesson. Be sure to save any files that you may have created with the previous software and copy it into the new directory. We augment all of the commands that you used before with a new -z option. This allows you to specify x, y, and z coordinates plus rotation angles of 0 to 360 degrees for each axis. The rotation angles are a convenience so that you don't have to calculate new x, y, and z coordinates. So here's an example of just some text, but now it's rotated in the z direction, and actually it's rotated in the y direction, sorry. And here are the commands that are used to rotate it. It's rotated 5 degrees in the x direction and 55 degrees in the z direction. And then you specify the text and the color. And what we'd like you to do is to type that into a new file and try it out. Another new option is a line width parameter, which is going to be part of the -z option. And this allows you to draw an outline figure or a filled figure. So for example, in this command, we have the x, y, and z coordinates. Then we have the rotation angles. Then we have a line width, then a width, and a height, and a color. If the line width is 0, you get a filled figure, and if the line width is non-zero, then you get a outline figure. This is a nice option for drawing outlines and then putting titles in the middle of the empty space. Fluffy, be quiet. You can also use the -z option on solids, as is illustrated in the figure. You're going to use a light command, as we did before, then a material command, and then for the solid, you're going to specify an x, y, and z, and then the rotation angles, and then the parameters and the color or the figure for the solid. You should also type in these commands and try them out. Moving pictures were invented about 1834 with the construction of the zoetrope, and this uses a spinning cylinder of slotted frames to view images and takes advantage of a weird characteristic of human vision. You should read about it at frame rate at wikipedia.org. The following slides illustrate the device, the strips of paper that go into the device, and what it looks like. Ta-da! The new command is .play, and it has the same options as .art. You say .play space hyphen, and it draws the default sequence of frames using pdraw.txt to draw each frame. And I'd like you to try it, and you'll see the initial title sequence. The question is, how does pdraw know which frame to draw, and how do we take a command like .rectangle and make it do different things? Well, what happens is when you say .play hyphen, it invokes .pdraw with a frame number. And these frame numbers go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 forever if you let the program continue to run. The pdraw program then takes the frame number and uses it to modify an x coordinate, a y coordinate, a rotation angle, all different kinds of calculations to make figures move around on the screen. But that raises the question of, well, how do you do a calculation? If you look at the example, you can see two quite powerful features of the M programming system. First, program fragments, and we'll be talking about programming more in future lessons, can be freely intermingled with commands. And secondly, commands themselves, if you parenthesize one of the parameters, can involve an expression involving references to anything in the programming language. And that feature is used to parameterize commands such as rectangle to, in this case, move a rectangle along the x-axis. The % is a common programming language operator, meaning remainder on division. So what it does is it takes the frame value 0, 1, 2, 3, 4, a million, 2 million, whatever, divides by 5 and takes the remainder. And if you remember your arithmetic, taking the remainder on division yields a value between 0 and the number that you're dividing by. So we get 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And that causes the rectangle to move along the x-axis and then skip back to 0, move along the x-axis. And try executing the command .play space pdemo. The result illustrates taking the rectangle parameterization and moving rectangles on the x-axis, the y-axis diagonally. Try modifying the program with different figures and try different calculations. The results can be pretty impressive. The animated sequences in this lesson were recorded using a screen capture app. Those are available for the Apple Macintosh as well as the PC. And what I'd like you to do is to try to duplicate a title sequence from any movie. You can look back at great movie title sequences that was referred to at the beginning of the lesson. And if you email them to me, then I'll collect them and post them so that you can see what other people are doing. Just send the program, don't send the output. And I'll run the programs and then collect them. So let's get moving.